Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, I will explain you one question from Cambridge ES Physics. This question is quite challenging and very confusing for many students at the beginning when they face this type of questions. In this video, I will not only explain this question, in fact, I will teach you one technique, and that technique you can use to answer a lot of questions in physics. For this question, it is given to us that at sea level, atmospheric pressure is 100 kPa and the density of air is 1.3 kgs per cubic meter. It is also given to us that we can assume that density of air decreases linearly with height above sea level. What we need to calculate, we simply need to estimate the total height of the atmosphere based on this information. The best way to answer this type of questions is sketching. First of all, sketch what is given to you. In this question, it is given to us that density of air decreases linearly with height. So you can see here I have already sketched the relationship between density and height. At sea level, when height is equal to 0, density is maximum, and when the height is maximum at certain height, density will decrease to 0. Now, as this is decreasing linearly, we can also calculate average density. So we can find out average density. Average density in this case is quite straightforward one because there is a linear relationship between density and height. So we can take the maximum value of density and we can take the minimum value of density and we can simply divide by 2. In this case, our average value of density is 0.65 kgs per cubic meter. We can also look at this one. As you can see, we have a cylinder that is filled with air. So density at this point when the height is equal to 0 is equal to 1.3 kgs per cubic meter, and at maximum height density is equal to 0. But this cylinder we can also simply replace with an other cylinder that has the same height but its density is average density, means it has uniform density. So we can assume or we can simply visualize like this. This is just for you to visualize. You can see, so its density is constant, or you can say its density is uniform. So I have drawn another cylinder. So for this cylinder, average density we have calculated, mean its density is equal to average density, that is 0.65 kgs per cubic meter. Now we simply need to find the height of this cylinder based on given information. As you can see, the value of P is given to us, so we can simply use P is equal to rho GH. Now, as the density is constant, mean if we take average density, we can assume this density is constant. And so simply we need to find the height. So it means the height is equal to P over rho G. So value of P is given, that is 100 kPa. So we simply multiply this one with 1000 and we can divide by average density and you can multiply with 9.81. So if we just calculate this one, the value of height we will get, that is 15.7, or we can say this is approximately equal to 16 kilometers. So our answer is B. This is our final answer. So this technique is very useful.